Hey guys, M2 here, and welcome to the first episode of my new series where I will explain to you all the different things that a mechanical engineer can do. In today's episode, we are talking specifically about aerodynamics. Accordingly, the gameplay you are watching for this video is a Forza 5 gameplay because aerodynamics plays an important role in the automotive world. But before we jump into the aerodynamic aspects of racing, let's take a step back and begin with the basics. Aerodynamics is a specific field of study within fluid dynamics, which is the study of how fluids behave. Fluids are classified as liquids or gases, so things like air, water, oil, antifreeze, CO2, oxygen, all of these things are fluids and have very specific properties. Aerodynamics is specifically interested in how solid bodies, so things like planes or cars, interact with fluids. It's best to begin our discussion of aerodynamics with a simple explanation of how airplanes are able to fly. The cross-section of a typical airplane wing is shaped in the way you see in the picture on the screen. This shape is called an airfoil, and there are many different types of airfoils, but all of them achieve the same thing. In order to explain how an airfoil works, let's start with a simple example. Suppose there are two ants on the leading edge of the airfoil shown in the picture. If the two ants began to walk across the airfoil at the same speed, one walking over the top edge and one walking over the bottom edge, the one walking over the top edge of the airfoil would reach the trailing edge after the one that walked over the bottom edge. This is because the airfoil is specifically designed so that the top edge is longer than the bottom edge. Now let's imagine air moving over the airfoil. The air begins at the leading edge, and some of it goes over the top of the airfoil and some of it goes underneath. But unlike the ants, all of the air has to arrive at the trailing edge of the airfoil at the same time. This means that the air moving over the top of the airfoil has to travel faster than the air moving over the bottom of the airfoil. When the air moves faster, the pressure the air exerts on the top of the airfoil is reduced. A simple way to think of this is removing air from a plastic bottle and realizing that the sides of the bottle begin to collapse. This is because once the air is removed, the pressure outside the bottle is greater than the pressure inside the bottle. So, because the pressure pushing down on the top of the airfoil is now less than the pressure pushing up on the bottom of the airfoil, there is a net upward force which causes the plane to begin to lift off the ground. This force increases as the plane moves faster because the pressure difference increases. Once the force pushing up on the plane is greater than the weight of the plane, flight is achieved. So how does all this apply to racing? Well, let's consider what would happen if we flipped the airfoil upside down so that the air moving across the bottom edge now has to move faster. This creates a downward force rather than an upward force. The spoilers of cars are designed in exactly this way, with an inverted airfoil. The force created by the spoiler is referred to as downforce. Formula 1 cars have spoilers on the front and the rear of the car to provide downforce. Remember that as the car moves faster through the air, the force generated by the airfoil increases. This downforce helps increase the handling of the car by helping the tires grip the racing surface. Because of this, if a Formula 1 driver takes a turn too slowly, the car won't have enough grip to make the turn. Now there are several other aspects to aerodynamics, but I just wanted to cover the basics in this episode, and I hope you guys did enjoy it. And that is going to conclude our discussion of aerodynamics. In the next episode, we will talk about the much broader topic of fluid dynamics and provide some other interesting examples. Be sure to subscribe to the Hardcore Union and check out my channel for the next episode of this series. I am M2, thanks for watching, and I'll see you next time.